Hello, students. This lecture series is titled Lives of the Noble Humans. It is a parody, I guess you could say, or a play on words of Plutarch's works, Lives of the Noble Greeks and Lives of the Noble Romans. Plutarch was a writer in Roman history, and he wrote biographies on pertinent people that existed in both Greek history and Roman history. And as a historian, I have chosen select figures, the brightest intellectuals of human history, and this lecture will be given in three parts, covering select individuals. The first is which is Aristotle, and then we will go into this lecture, starting with Copernicus, and then going into Francis Bacon. First, I would like to give an introduction. When I reflect upon the time in which I find my existence, I think upon the times of people, their greatest thoughts and achievements, and all their faculties. It is only natural as one who inspires others to be naturally inspired by others who have been inspired themselves. Throughout history, there have, throughout the past 6,000 years, to which historical writings can be translated, read, interpreted, and digitally analyzed, been select robust individuals who have changed the course of history, both by their virtue and by their vice. These individuals, I leave the reader free to determine for themselves, are of tremendous pertinence to those who have sought to emulate the best attributes and qualities of humankind in literature, politics, science, philosophy, history, art, music, and architecture. Of course, when individuals shine on their own merits, their real brilliance is revealed, untainted by the thoughts of others concerning their reputation. Their true character and intentions are indicated through their writings and their actual lives, lived out in real time, regardless of the century and the extent of their acquired knowledge, as a historical timepiece represented by a date of birth and a date of death. Naturally, one might reflect upon figures who were the most important with regard to the general progression of the human species, but I advise that discovery and intellect, knowledge and power, the result of the former, have absolutely nothing to do concerning one's character and individual personality, and that an admiration does not necessarily entail that the person being the object of admiration should be admired at all. In my biographies on pertinent people from past and present, I recognize that the pertinence of a person's life is oftentimes not even realized in the person's lifespan, but centuries or even millennia later in time. This is a story concerning the lives of noble humans. I have chosen select figures whose lifespan represents an entire history of phenomena, sometimes known through a generic competency, but not known due to a necessary specific comprehension, that pervaded throughout the life of the individual being studied, whether it be General George Washington or Elizabeth II, Queen of England. I have also chosen individuals of high intellect and repute who have existed over the past 500 years, say from the time of 2076 CE, which has not occurred yet, all the way back to 1576 CE. My specialization being the products of the Renaissance thought and the Enlightenment ideals and principles. Each figure, with their historical context, paints a picture of the pleasant and not so pleasant pains of the person's past and the implications and applications that can be drawn from a diligent inquiry concerning their life and times. Salutary successes and flicking failures, their passions and popular opponents, their visions victorious and their drowning doubts. The prelude, the only exception to these contents, is that of Aristotle. The figures, however, are the central methodological and philosophical texts that comprise the scientific revolution of the 17th century. Born in 384 BCE at Stagira, Macedonia, Aristotle spent 20 years of his time a pupil of Plato's academy and established his own school in Athens, the Lyceum or Peripatetic School in 335 BCE, the very center of Greek learning, but for a span of 10 years, Elements of his thinking, empiricism, essentialism, naturalism, and teleology, survived the Middle Ages and the intellectual revolution of the 17th century, respectively. An adequate understanding of the new science of Galileo, Newton, and Einstein, for example, are limited without a general comprehension of Aristotle's worldview, against which a new and improved worldview was forged. Central to Aristotle's thought was his concept of nature. And so here we see that pardon me, but I might delve into another discourse on Q.V. Quine, who you can also look up the National Academy of Sciences, the American Philosophical Society, the American Academy of Arts and Sciences. Pertinent terms for Quine was observation and self-evidence, testimony and hypothesis, induction, analogy, institution, confirmation, refutation, explanation, persuasion, and evaluation. Quine goes over the study of rational belief and philosophy, the theory of knowledge, the methodology of science, the philosophy of language, and he quotes that nearly any body of knowledge that is sufficiently organized to exhibit appropriate evidential relationships among its constituent claims is understood as scientific. Science is the product of rational investigation, and such inquiry often demands a vast background of knowledge, because human knowledge has progressed extensively. What is needed for historical and scientific inquiry is receptivity to data, skill in reasoning, and the desire for truth. But science is that beautiful discipline which brings enlightenment, literature and the arts of history, music, poetry. Cognitive comes from a Latin word meaning acquiring knowledge. Superstition and belief are as old as humanity itself, and so let the transcendence of facts and our limitations in controlling them be praised due to their power, given that humans have, for the most of its existence on this planet, has not been able to reflect in an age where it is popular to distrust the established views of the time period. Aristotle is one such figure. His concepts of nature was not materialistic, nor was it Platonistic, for nature was differentiated into various species and objects, all having their own internal and essential dynamic for change. Their alteration was the progressive teleological actualization of a pre-existing potential. Science, according to Aristotle, was largely concerned with the understanding of natural changes in the world. Philosophers like Aristotle were only interested in objects and anything that revealed the true nature of the objects in question. The naturalism of Aristotle indicates that science is that which shows us things about the real, actual world that we live in and observe around us, where experience is the only true test. When one puts Aristotle in comparative perspective, one understands that the medievals had good reason to think that there could not be a knowledge of nature without a basic knowledge of motion. For the foundational laws of dynamics reveal ontological and epistemological treasures useful in free inquiry. Aristotle wrote extensively on science, but also ethics, politics, astronomy, biology, and religion, etc., including the first comprehensive treatise on scientific methodology, which is why he is included in this lecture list. His posterior analytics and his physics exhibit such things. These works would set the agenda for over 2,000 years of discussion, and indeed Galileo Galilei was an avid reader and student of Aristotle's treatise, which constitutes what it is to explain something, the place of perception in natural philosophy, and whether certainty and absolute truth are actually attainable in science. For this information, you can see the work titled Aristotle the Philosopher, in 1981, published work from Oxford University Press, and the author is Acril, J.L. Acril. As far as Copernicus is concerned, he wrote such things as the Commentarilius in 1512, and on the revolutions of the heavenly spheres in 1543. And during the life of Nicolaus Copernicus, Columbus discovered the New World in 1492. And at the same time, Copernicus was only 19 years of age. Also at this time, Martin Luther's 95 Theses were written in 1517, which indicates the religious superstitions happening in this century. Keep in mind that both theories, the first being a non-rotating Earth-centered theory by Ptolemy in 150 CE, and the second being a heliocentric solar system with the rotating Earth by Nicholas. This was the answer to the astronomical task enunciated by Plato. Copernicus was born in Poland of German parents, 20 years after the Turkish capture of Constantinople in 1453, precipitated by the migration of Eastern scholars and their libraries into Western Eurasia. He studied law, medicine, theology, Greek, and Latin in Italy, where he benefited from a study of Plato, given its recent rediscovery at that time. And in 1512, he circulated the first draft of the Commentariolus of his epochal heliocentric, non-geocentric theory of the solar system. The final version, On the Revolutions, was published in the year of his death in 1543. C. Pierce Dunham and his work To Save the Phenomena, a publication by Chicago University of Chicago Press, 1969. Quote, in the very words of Simplicius, Plato marks the principle that the heavenly sphere's motion is circular, uniform, and constantly regular. Thereupon he sets the mathematicians the following problem. What circular motions, uniform and perfectly regular, are to be admitted as hypotheses so that it might be possible to save the appearances of the planets presented by the planets? And there was, in Copernicus's time, an accumulated mass of information already at Copernicus's disposal, i.e. the times of the rising and setting of the planets, the periodic reversals in their constant easterly paths, the changes in their perceived brightness, the relative position of the planets against the stars, etc. And Plato's question illustrates my main point here, that there was at this time an interconnection between philosophy, physics, and mathematics that characterized the astronomical and scientific tradition. I have noticed two great constraints. One, that philosophy at the time of Copernicus dictated that there was order behind the planets' appearances, that their movements were also constant and regular. And second, that mathematics told philosophers that the most perfect movements were circular, and as I have indicated, this limited the models that astronomers could produce. Ptolemy, previously, had set forth an anti-realist instrumentalist tradition in astronomy with his model of circular deference, epicycles, and eccentrics. It was a complicated model, but it was consistent with common sense, philosophy, physics, and the poisonous consequences of religion. Ptolemy had put aside the question concerning the actual mechanism for planetary motion, and rather concentrated his focus on perfecting his epicyclic model. Indeed, at the time of Ptolemy, how the planets moved was of little concern for mathematical astronomy, provided that the model was in agreement with how they appeared to move. Copernicus answered Plato's question by changing the reference of the solar system, geocentric, to heliocentric. Indeed, the Copernican system simplified celestial physics but greatly complicated terrestrial physics as a result. A spinning, revolving Earth had counterintuitive and counter-experimental consequences, for Copernicus did not provide a new physics in order to support his new astronomy, nor a new epistemology, nor a new theological interpretation in explaining away the inconsistencies of texts which are diametrically opposed to a moving Earth. Nevertheless, Copernicus was convinced that his system was the actual system of the world at that time. It was truth, and with only 150 years, the combined efforts of Johannes Kepler, Galileo, and Sir Isaac Newton would eventually sweep away to varying degrees the old philosophy and theology of the ancient world and the medieval world, and would provide a new modern physics of eternal motion and force, all of which constituted the Copernican Revolution, a movement in which science and philosophy were historically inseparable. See Thomas S. Kuhn on the Copernican Revolution, a New York publication, 1957. I also covered the life of Bacon. I invite you here to read a nice article written by Mary Horton in defense of Francis Bacon. It can be found in the journal Studies in the History and Philosophy of Science, 1973. Francis Bacon wrote the New Organon. His first work, of course, I will go over in a bit, and then we will go over some other authors later in another lecture. Francis Bacon was the most pertinent English philosopher of the Renaissance period, the late Renaissance period. Born in 1561, Bacon entered university at the age of 12. After studying Plato, Aristotle, and the scholastics, he graduated at the age of 15. A year later, an assistant ambassador to France at the age of 25 in 1586. He commenced a 36-year career in the English Parliament, and being made Lord Chancellor in 1618, he spent the last 4 years of his career as Lord Verulam, retired in 1622, and died 4 years later in 1626. His first major philosophical work was called The Advancement of Learning, and it was published in 1605. Note that he also studied law. Note that Bacon studied at Trinity College at Cambridge. He was the King's Counsel from 1604 to 1606. He was Solicitor General from 1607 to 1611. He was the Attorney General from 1612 to 1615, Privy Councillor in 1616, and then Keeper of the Great Seal in 1618. Lord Chancellor Verulam's death in 1626 followed 80 years after that of Luther and Copernicus, occurring while Galileo, Kepler, Harvey, Descartes, and others were forging the steel of a new science. Bacon was greatly esteemed by the succeeding generation of philosophers and scientists, i.e., Robert Hooke makes the reference to him in his Micrographia in 1665, and the founding members of the Royal Society eulogized him. In 1781, Immanuel Kant dedicated the Critique of Pure Reason to Francis Bacon. In regard to Bacon's thought, Aristotelians cannot be reformed. One has to begin anew the human quest for knowledge. The new method Bacon proposes is inductivism. Unlike Bacon, John Stuart Mill was not the originator of British empiricism. Francis's epistemology was developed on the correct assumption that there is an external world that a perceiving subject confronts and gains knowledge of through impressions of the senses. The less that the subject contributes, the more truthfully nature can speak. If you take a peek, say, at Bacon's preface to the Great Instauration, a brief promissory note detailing his division of the sciences, he opines that success in science, quote, all depends on keeping the eye steadily fixed upon the facts of nature and so receiving their images simply as they are, end quote. John Stuart Mill understood this idea of immaculate perception as it had become a leading motif of empiricism. Bacon is highly regarded for detailing the causes of faulty cognition, i.e. his short aphorisms on the idols of the mind are harbingers of modern studies in linguistics, social and evolutionary psychology, perception, and as well as ideology. Indeed, humans recognize that language, class, ethnicity, and individual human interests all affect perception and judgment. In 1622, Bacon was disabled from sitting in Parliament due to a 1621 bribery charge, of which he was pardoned in 1624, but he spent the last 2 years of his life devoted to writing literature. And aware, Bacon knew that the theoretical frameworks that determine what and how things are observed in real time, sound observational foundations upon which to inductively create a secure science, were extremely important. I only briefly mention one of my other heroes, Auguste Comte, who developed this program in the 19th century. 300 years later, its further development occurred in the 20th century. See also A.J. Ayer, Logical Positivism, written in 1959, and F. Soup, The Structure of Scientific Theories, written in 1977. In the next lecture, we will discuss Galileo and René Descartes. Thank you.